Hi friends, in this session we will study about the minors and cofactors of a matrix. Here I let tell you about the minor. Let A is equal to Aij be a square matrix of order n, then the minor Mij of Aij is A is the determinant of the square submatrix of order n minus 1 obtained by leaving ith row in j column of A. So let us take an example here. A is equal to, there is a matrix of order 3. We have 1 2 3, 1 2 3, minus 3 2 minus 1, minus 3 2 minus 1, and 2 minus 4 3. This we have a matrix. Okay, now we have to find out the minors of this. This is the matrix of order 3. The minor of determinant we get in order 2. Okay, so because the n minus 1 order determinant we get over there. So M11 get here, M11 it is A11 is 1, so we have to leave this row and this column. The remaining elements we have to write in the form of determinant. 2 minus 1 minus 4 3. Now we have to find the value of this determinant. Is the main diagonal we will multiply 2 into 3 minus of diagonal we have to subtract from this main diagonal, minus 1 into minus 4. So we get here 6, and minus 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 we get here minus 4. 1 times 4, it is 2 now. It is 2. Now we have to find out M12. M12 first row, second column. It is the first row and the second column is this. So it is the 1 2 element, E12. We have to leave this column and this row, and the remaining element we have to put minus 3 minus 1 2 3, minus 3 minus 1 2 3. So we get here minus 3 into 3 minus 1 into 2. We get here minus 9 plus 2, we add here minus 7. So it is the value of determinant of 1 to M1. This is the value of M1. Now we find M13. M13 is 3. A13 is 3 here. So this column and this row we have to leave, and other elements we have to put it into determinant form. Minus 3 2 2 minus 4. Minus 3 2 2 minus 4. Now we solve this. Minus 3 minus 4 minus 2 into 2. So we get here 12 minus 4, which is equal to 8. Now M21. M21, for A21 there is minus 3. So we have to give this row and this column. The other remaining element 2 3 minus 4 3. 2 3 minus 4 3 we have to put here. Now we get here 2 multiplied by 3 and subtract this of diagonal 3 multiplied by minus 4. So we get here 6 plus 12, which is 18 now. Now M21, sorry, M21 we have taken already. So M22 here, A22 is this one 2. So the remaining this column and this row we have to leave, and we have to put the 1 3 2 3. 1 3 2 3. Now we simplify this. So it is 1 into 3 minus 3 into 2. We get here 3 minus 6, which is minus 3. Now M23 A23 element is minus 1, so we have to leave this column and this row. Get minus 3 to 2 minus 4 minus 3 2 minus 4. This we have to get here. Now simplify this. Minus 3 into minus 4 minus 2 into 2. So we get here 12 minus 4, which is 8 now. And now M31 minor 31, yeah, final minor 31 A31 is the element 2, so we have to leave this column and this row. 2 3 2 minus 1 2 3 2 minus 1 2 3 2 minus 1. Now we simplify this. It is equal to 2 minus 1 into 3 multiplied by 2, sorry, 2 minus 1 minus 3 multiplied by 2. So we get here minus 2 minus 6, which is minus 8 now. So now M32 A32 element is minus 4 here. So we have to leave this row and this column. 1 3 minus 3 minus 1. 1 3 minus 3 minus 1. So we get here 1 into minus 1 minus 3 into minus 3. So we get here minus 1 plus 9, which is again 8. Now we have the last element, minor of last element, M33. The last element A33 is 3. So we have 1 2 minus 3 2. 1 2 minus 3 2. We have this. Now we simplify this. So it is 1 into 2 minus 2 into minus 3. So we get here 2 plus 6, which is 8 again. So this we have got all the minors here. Now through this minus, if you have to find out the value of the determinant of matrix A, how we get this? So you see here, it is a matrix A, and we have to use the sign convention approach for this, the positive, negative, positive, negative, positive, negative, and positive, negative, positive. The alternate signs, we have to use the positive, then negative, then positive. In this way, I have to type this thing. So we put, if we have to find out the value of determinant, so we have to follow this sign convention through the minors. So we get, if we have to find out the value of determinant of A, I change the color here, determinant A, sorry, is equal to A11, M11, it is the positive, the first sign is positive, the first sign is positive, the second A12 we have to take the negative sign, minus A12, M12, then we have positive sign there, A13, M13, this is the value of determinant. We can take any row and column, we can select. If we have to find out the determinant, if we get the determinant through this, then I explain in some other way also. So here you see A11 is 1 and M11 is 2. 1 multiplied by 2 minus A12 is 2 and M12 you see here, look at this. A12 is 2 and M12 is minus 7. 2 into minus 7. Then A13 is 3 here, A13 is 3 and M13 is 8. Now we get here 2 plus 14 plus 24. So we get here 24, 28, 38 and 40. This is the value of this determinant A. We could easily find out this value through any row or column. Now I will explain you with other column, with some other column. So we get column, this second column we are taking as. So for second column, if we take determinant of A through the second column, it is 1 2 M12. The second column, it would be negative, where there is the sign convention. If we use here the sign convention, for this we have to take negative, positive, negative. So we have to choose the negative sign here. We have to put here then positive A22 M22, then negative A32 M32. Now we look what happens if we put these values. A12 is 2, A12 is 2 and M12 is 7, minus 7. So 2 multiplied by minus 7. Here is a minus sign is already 2 multiplied by minus 7. A22. A22 is again 2 and M22 is minus 3. It is minus 3 here. So 2 into minus 3. Now negative sign A32. A32 is minus 4 and M32 is 8. So it is minus 4 into 8. Now we simplify this. It is 14, it is minus 6, it is 32. 14 minus 6, it is 8 plus 32, we get here 40. The value of determinant we always get same if we choose any row or any column. So this is the way how to find out the minor. Now we study about the cofactors. Cofactor is minus 1 to the power I plus j times of minor. It means Cij is equal to minus 1 power I plus j mij. Let us see if you have to find out the C11. Then minus 1, I is 1, j is 1, 1 plus 1, M11. So we get here minus 1 power 2 and M11, the value of M11 we have already find it out here. M11, the value of M11 is 2. So we put here 2. So we get minus 1 power 2 is 1, so we get here 2. Now C12 minus 1 power I is 1 and j is 2, so into M12 we get here minus 1 power 3 and the value of M12 we have already find it out is minus 7. So we put here minus 7. So we get here minus 1 to the power 3 is minus 1 and minus 7 we get here 7, positive 7. C22 the same way C13 we could get in the same way. So in this way we could easily find out the cofactors of any square matrix. So C13 minus 1 to the power 1 plus 3 M13 and minus 1 to the power 4 and we know the value of M13 is here. M13 is 8. It is 8. M13 is 8. We have to put here 8. We got the even power, we get 1 here, so we get the value of 8 here. And C21 cofactors 2, 1, we have to get minus 1 to the power 2 plus 1 and M21. So we have to get here minus 1 to the power 3 and M21 we know already here. M21 is 18. M21 is 18 here. So we put here 18 now. So it is minus 1 because it is odd power into 18. So we get here minus 18. And C22 is equal to minus 1 to the power 2 plus 2 M22 and minus 1 to the power 4 and M22, know that here M22 is minus 3. We have to put here minus 3. So we get here minus 3 and C23 which is minus 1 to the power 2 plus 3 M23 minus 1 to the power 5 and the value of M23, look at this, value of M23 is 8. Now we have to put here 8. We get here the odd power is there, so minus 1 into 8 which is minus 8. Now C31 minus 1 to the power 3 plus 1 M31, it is minus 1 to the power 4 and M31, we have the value here M31 is minus 8. We have to put here minus 8 again and it will become minus 8 only because it is an even power. C32 which is minus 1 to the power 3 plus 2 M32 minus 1 to the power 5 and value of M32 we have 8. It is 8 here. We get here it is odd power, so minus 1 into 8 is minus 8. And C33, the last one cofactor of this 3-order matrix, sorry, 3 plus 3 M33. So get here minus 1 power 6 and this value is also 8 over there, so it is 8. Okay, so this we have got the cofactors. Now we have to find out the value of the determinant through the cofactors. So we have to apply, there is no sign convention we have to apply, we just had to add this all in a proper way, so we could easily find it out. So I change first. So determinant of E through cofactors. So we follow A11, C11 plus A12, C12 plus A13, C13. There is no sign convention rule we have to apply because the cofactor, if there is a odd number, the summation of I plus j, it will already give us the negative sign. So this is the plus a sign, always we have to take the plus sign in between. So A11 we know that it is 1 here and C11 we know that A11 is 1 and C11 we know that it is 2. We have to put here 2. A12 is 2. A12, the second element. A12 is 2 and C12 we look at this. C12 is 7. We have to put here 7. A13 is 3 and C13 I explain you here. C13 is 8. So we get here 2 plus 14 plus 24, so you get here 14. So by any row or the column we could apply this cofactor, and using this cofactor we could easily find the determinant of any matrix, any square matrix. So this was our session about the cofactors and minors and how to find out the value of determinant of any square matrix through the cofactors and minors. Thank you.